Hey there, science fans. Have you ever wondered what makes our modern world tick? I'll give you a hint. It's not magic. Though it seems like it sometimes, it's metals. But not just any metals. We're talking about metallic alloys. Think of a skyscraper reaching for the clouds or a rocket ship blasting off into space. These engineering marvels rely on materials that are super strong, resistant to heat, and won't rust easily. That's where metallic alloys come in. They are like metals with superpowers. Alloys are formed by mixing different metals and sometimes even a pinch of non-metals to create something truly extraordinary. They are the hidden heroes in everything from our smartphones and airplanes to bridges and medical implants. So buckle up as we dive into the fascinating world of metallic alloys and discover how these incredible materials shape our lives. Get ready for some serious science fun. Let's get down to basics, science crew. A metallic alloy is a mixture of two or more elements where the main ingredient is a metal. It's kind of like baking a cake, but instead of flour and sugar, we use metals like iron, aluminum, or copper. Now you might be thinking, why bother mixing metals? Why not just use pure metals? Well, the truth is, pure metals can be a bit, limited. Take gold, for example. Pure gold is beautiful and doesn't tarnish, but it's also very soft. You wouldn't want a pure gold hammer, would you? It would bend out of shape after a few swings. That's where alloys come in. By mixing metals, we can combine their best properties and overcome their weaknesses. Adding a bit of copper to gold, for instance, creates a harder, more durable alloy, perfect for making jewelry. So remember, alloys are all about teamwork. By combining the unique properties of different elements, we can create materials that are stronger, tougher, and more versatile than any pure metal could ever be. There are a couple of main ways we can create these super-powered metal mixes. The first type is called a substitution alloy. Imagine a bunch of metal atoms all lined up, holding hands like kids in a schoolyard. In a substitution alloy, some of these atoms get swapped out for atoms of a different element. Think about it like this. You and your friends are playing tag, and suddenly a new kid comes along and wants to join in. You make some space, and now you have a more diverse group of kids playing. That's kind of what happens in a substitution alloy. The new atoms sneak in and take the place of some of the original ones. One of the most common examples of a substitution alloy is brass. This shiny golden-colored metal is made by adding zinc atoms to copper. The zinc atoms replace some of the copper atoms, resulting in a material that is stronger and more resistant to corrosion than pure copper. This makes brass perfect for use in musical instruments, plumbing fixtures, and decorative items. The second type of alloy is called an interstitial alloy. This time, instead of swapping places, the new atoms squeeze into the spaces between the existing metal atoms. Think of it like adding marbles to a jar already filled with tennis balls. The marbles fill the gaps, making everything more compact. A great example of an interstitial alloy is steel. Steel starts with iron, which is strong but can be brittle. By adding small amounts of carbon, we create steel, which is much stronger and tougher than iron alone. The carbon atoms are small enough to fit in the gaps between the iron atoms, making the entire structure more tightly packed and resistant to deformation. Interstitial alloys might sound like small potatoes, but they play a huge role in our world. Steel, for example, is used to build everything from bridges and skyscrapers to cars and airplanes. So the next time you see a towering skyscraper, remember those tiny carbon atoms holding it all together. Section 5, everyday alloys. From your kitchen to your car, alloys are everywhere. You don't have to look far to find examples of these incredible materials hard at work. Let's take a look around, shall we? In your kitchen, you might find stainless steel pots and pans. Stainless steel is an alloy of iron, chromium, and nickel. The addition of chromium makes it resistant to rust, while nickel adds strength and shine. Your cutlery might be made of silverware, another alloy of silver, copper, and sometimes zinc, known for its durability and beautiful shine. Head outside and you'll find alloys in cars, bikes, and airplanes. The frame of your bicycle might be made of aluminum alloy, which is lightweight yet strong. The engine of your car relies on a variety of alloys, each carefully engineered for specific purposes like heat resistance and wear resistance. And of course, airplanes use lightweight yet incredibly strong alloys in their wings and fuselage to soar through the air. Section 6, alloy advantages: stronger, tougher, longer lasting. So why do we love alloys so much? Well, they offer a whole bunch of advantages over pure metals. One of the biggest benefits is increased strength and durability. Alloys are often much stronger and harder than their pure metal counterparts. This makes them ideal for applications where the material needs to withstand heavy loads, impacts, or wear and tear. Think of the rugged undercarriage of an off-road vehicle or the sturdy frame of a skyscraper. These applications demand the strength and durability that alloys provide. Another major advantage is corrosion resistance. Corrosion is a natural process that can weaken and damage metals over time. However, certain alloys, like stainless steel, are highly resistant to corrosion. This makes them ideal for use in harsh environments, such as kitchens, bathrooms, and outdoor structures. But that's not all. Alloys can also have improved electrical and thermal conductivity, making them suitable for use in electrical wiring and heat exchangers. They can be engineered to have specific melting points, which is essential for applications like welding and casting. And let's not forget about aesthetics. Alloys can be polished to a beautiful shine and come in a variety of colors, making them perfect for everything from jewelry and decorative items to high-end watches and luxury cars. Section 7. Making alloys, mixing metals like a chef. Creating alloys is a bit like following a recipe, with a dash of science thrown in, of course. There are several methods used to mix metals and create alloys, each with its own advantages and disadvantages. One common method is called melting and mixing. As the name suggests, this involves melting the different metals together in a furnace. Once melted, the metals are thoroughly mixed to ensure a uniform composition. The molten alloy is then poured into molds to cool and solidify. This method is relatively simple and versatile, making it suitable for producing a wide range of alloys. Another method is called powder metallurgy. This process involves grinding the constituent metals into a fine powder. The powders are then mixed together and subjected to high pressure and temperature. This causes the powders to bond together, forming a solid alloy. Powder metallurgy offers greater control over the alloy's composition and can be used to create alloys with unique properties. Choosing the right method depends on factors like the desired alloy composition, the required properties, and the intended application. Metallurgical engineers carefully select the best method to create alloys that meet the specific demands of various industries and technologies. Section 8. The future of alloys. Lighter, stronger, more amazing. The world of alloys is constantly evolving. Scientists and engineers are always on the lookout for new and innovative ways to create alloys with even more impressive properties. One exciting area of research is in the development of lightweight alloys. These alloys are designed to be as strong as traditional alloys, but with significantly reduced weight. Lighter alloys are especially important in the aerospace and automotive industries, where reducing weight can lead to improved fuel efficiency and reduced emissions. Imagine airplanes that can fly farther on less fuel, or cars that are faster and more agile. Another promising area of research is in the development of high-entropy alloys. Unlike traditional alloys, which typically consist of one or two primary metals, high-entropy alloys are made up of 5 or more metals mixed in roughly equal proportions. This unique composition results in alloys with exceptional strength, toughness, and corrosion resistance. High-entropy alloys have the potential to revolutionize industries ranging from aerospace and energy to medicine and electronics. The future of alloys is full of possibilities. As we continue to explore the world of materials science, we can look forward to even more incredible discoveries and innovations that will shape the world around us. Section 9. Keep exploring. The world of materials needs you. So there you have it, science explorers. We've journeyed into the fascinating world of metallic alloys and discovered how these incredible materials are essential to our modern lives. From the skyscrapers that pierce the clouds to the smartphones in our pockets, alloys are the unsung heroes that make our world go round. But our exploration doesn't end here. The field of materials science is vast and constantly evolving, with new discoveries waiting to be made. Who knows what amazing new alloys the future holds? Maybe you'll be the one to discover them. Remember, science is all about curiosity, creativity, and a passion for understanding the world around us. So keep asking questions, keep exploring, and never stop learning. The world of materials needs your bright minds and innovative spirit.